So 200 grams of a carbon compound was analysed and found to contain 122.4 grams of carbon, 23.8 grams of hydrogen, and the remaining part was oxygen. Determine the empirical formula of the carbon compound. Okay. So the mass of the carbon is this, from the question. Mass of the hydrogen is this, from the question. And the mass of the oxygen is just 200 minus 122.4 minus 23.8, which gives you 53.8 grams, okay? Because it says the remainder is oxygen. So that's this is what we get told in the question, okay? So we're gonna convert this to moles now, because we can't really use mass at all. We need to use moles, because mass is a way of counting how much matter there is. We need moles to count how many atoms there are in a particular molecule. Okay, so that's what we're going to do. We're going to convert all of this to moles now. And then we're going to do that by using m, the mass, over the molar mass. Okay, so for the number of moles of carbon is 122.4 divided by 12.01, which is 10.192. Okay, then we do the same for hydrogen, 23.8 over 1.008. These numbers here, the molar masses, you look up on your periodic table. 23.61. Again, you look up on your periodic table, and we get this from our question. 53.8 over 16, which is 3.363 moles. Okay, so now we have all the moles. And now we want the mole ratio. So number of moles of C compared to H compared to O. There's 10.192 moles of carbon for every 23.611 moles of hydrogen for every 3.363 moles of oxygen. Okay, so there it is. But that looks really ugly. You can see like there's all these decimal points everywhere. So maybe if we divide by one of these numbers, it'll take away some of these decimal places. Now the easiest thing to do would be to divide by the lowest number, so you end up with 1 as the lowest possible number you can get. Okay, because you don't want to get fractional numbers, because that just weirds people out. So you just divide by the smallest number, which is 3.363. So we divide each of these numbers by 3.363. And you get 1 here. So 3.363 divided by 3.363 is 1. 23.611 divided by 3.363 is 7.02. And 10.192 divided by 3.363 is 3. Okay? So that's the mole ratio. So the final empirical formula of the equation, so it's basically 3 carbons for every 7 hydrogens and 1 oxygen. So the final empirical formula would be C3H7O. Okay, so that's the empirical formula. That's how you calculate an empirical formula based on some kind of ultimate analysis that's given in the question. Okay, so quite a lengthy process, but nothing that you can't handle at this point. Okay. It's just knowing the steps, that's all. You just have to use your mole formula, and then the trick is here, that's all. Okay? Calculating the mole ratio.